Good day, everyone. I am Roel Pidelgo Jr., and I am going to present to you the Google site of Group 4 in this subject, Earth Science. So now our Google site is divided into 5. We have the home, the activity, the discussion, the summary, and the try this. So now let's uncover our Google site. First, in home, we have here our motivation, the overview, and the objectives. So first, Ruel Pidalgo Jr., this is a motivation. Second is Ocean Waters by Ma'am Beverly Gallardo. She also put the learning objectives and the overview of the ocean waters. Next is the ocean floor. The presenter is Ma'am Mary Jane Dumactol, and she also put the overview of the topic. We also have, and the last but not the least, is Mom Irish Beth Aya, the topics, tides, currents, and waves. And here is the overview of her topic. So these are the things that you can find on home. Activities here, and the students are encouraged to be engaged with these 6 activities. And now for the summary, we have different strategies and approaches in representing our summary. Earth, water in general. The other one is through also summary with visual representations, but this is through PDF. And also there's a trivia there. And there is also some kind of trivia for the ocean floor. And this one is the summary also of tides, currents, and waves. And for the try this is actually the evaluation part, wherein the students will answer some different kinds of assessment. And also for follow-ups, we have these useful resources that talk about water. So they just click the bar found below. We have 1, 2 bars here. So they're just going to click it. They will be on a website that talks about the water. Some information about the water, very interesting here. So that's it, our Google site. I hope that you learned and you enjoyed. And we also have different kinds of approaches. And I hope that you will apply some of it. Have fun learning, everyone. Hello there. My name is Ruel P. Dialogo Jr., and I am going to talk about the Earth waters. My objectives at the end of this discussion, the students will be able to 1. Discuss hydrosphere, hydrology, hydrologic cycle, and other kinds of water. Second, uncover and reflect the composition of earth water. And the third one is to trace the hydrosphere in its interaction with earth system. Water world. The hydrosphere is formed by the collection of water on our planet, in the ocean, on the ground, and in the atmosphere, making it a water world. However, as our knowledge grows, we've discovered that Earth isn't the only water world. Did you know that planet Earth is nicknamed as blue marble? It's because of the emerging presence of water if you're going to see some photographs of it. The total amount of water on a planet is referred to as hydrosphere. The hydrosphere is made up of water on planet's surface, underground, and of course in atmosphere. Collectively, all of this water forms the Earth's hydrosphere. Water is critical to life as we know it, which is why researchers are studying how water cycles through hydrosphere and how this precious resource can be conserved. We also have this field in science, which is the hydrology. It is the study of water distribution and movement on and beneath the Earth's surface, as well as the effects of human activities on water availability and conditions. So they study the behavior of waters, the fluid mechanics behind it, and the person responsible of this field are called hydrologists. Now we have this hydrologic cycle. We are familiar with this as this is called water cycle. This is actually the exchange of water between the land, the ocean, and the atmosphere on Earth. All three places have water, and it comes in variety of forms: lakes, rivers, glaciers, and ice sheets, ocean and seas, underground aquifers, and vapor in the air and clouds. So let's examine the animation of the hydrologic cycle. Most of the water that evaporates from the oceans return to the oceans as precipitation. So you see, here are the precipitation. The precipitation that falls on continents returns to the sea via runoff, or in here, the surface runoff. And also we have the, it will also go to the moving groundwater here. And others, it also may return to atmosphere via evaporation and transpiration, which is which is found on plants. The hydrologic cycle is not only described as the movement of water, it also the primary mechanism for the movement of energy from one part of the globe to another. So in continuation to the hydrologic cycle, much of the rain that falls on land seeps into soil and bedrock to become groundwater. We have these two terms. We have the porosity and the permeability. Porosity is the production of rock or soil that consists of open space. The permeability is the ability of the soil or bedrock to transmit water. Groundwater saturates the upper few kilometers of soil and bedrock to a level called the water table, which separates the zone of saturation from the zone of aeration. And we also have this aquifer. It is a body of rock or a rock formation that can yield economically significant quantities of water, and aquifers are porous and permeable. So now let's have a break by listening to this song, the water cycle song. So just click to this button. So now let's proceed with the earth water composition. I am going to show two visual representation that represents the earth water composition. One is a bar chart and the second one is a comparison of the size of the earth and the size of the total water here on earth. This is from Igor Shiklomanov's chapter World Freshwater Resources and Peter H. Glake as editor in 1993. So we have three bar graphs here. The first one is the total global water. We have the ocean, which comprises of 96.5%. We have the other saline water, 0.9%, and the fresh water, which is only 2.5%. And that fresh water is divided also into three compositions. We have the surface or other fresh water. We have the groundwater and the glaciers. So we have the ice caps. It comprises of 68.7. So, and the surface and the other fresh water, that 1.2 is also divided into ground, ice, and permafrost. We have also lakes. The other, we have the atmosphere, the living things, rivers, swamps, marshes, and the soil moisture. So we have this blue sphere depict the relative amounts of Earth's water in relation to the size of the Earth. Are you astonished by how little these water spheres appear? So as you can see, this is the whole Earth, and there are three blue circles there. So let's magnify this. As you can see, we have here one, two, and three. The big one is all water on, in, and above the water earth. And then this second is the liquid fresh water. And this very minute one is the fresh water found in lakes and rivers. So you see, ocean only make up a thin film of water on the planet's surface. So what are your thoughts about knowing the earth water composition? I want you to make a reflection to it by clicking this button. Now, let's proceed to the different kinds of water. We have the groundwater, we have the running water, and we have the flood. So the first one, we have the groundwater. The groundwater fills the spaces between the soil particles and fractured rock beneath the earth's surface. Now we have the running water. The running water, example of this is the stream. And streams are most common in most lands. About 20 to 25% of annual rainfall becomes runoff. And the energy of this runoff wears away the land and transports sediment to the ocean. We all know that flood is an abnormal rise of water. This occurs during if there are storms or typhoon, if there are heavy rains. And according to UNESCO, they defined it as a rise and usually brief in the water level in a stream or to a peak from which the water level recedes at a slower rate. That is from the 1974. And in 1942, by Lindsay, she defined it as a flow of water in a stream constituting a distinct progressive rise and culminating a crest. We cannot avoid the flood. That's why we need to be knowledgeable about the disaster readiness and risk reduction. For more information about the flood, click the button. It will lead you to the site of the Philippine Atmospheric, Geophysical, and Astronomical Services Administration. I am going to feature to you a Pinoy scientist, Dr. Leonardo Yongson. He is an academician, a national scientist. He is a renowned Filipino expert in the field of hydrology, hydraulics, and water resources, engineering and management, flood control, lahar flow control, and disaster mitigation. And for the last one, I want you to click this button for you to be able to know the programs of the Department of Science and Technology about water. So we have this wave of action, the WST water programs and technologies. So that's it, my topic about the earth, water. I also included the flood and also the Pinoy scientists and the programs of the Department of Education so that we will know that the government is actually having programs and taking actions.
Good morning, Doc. Good morning, teachers. So I am Beverly D. Gallardo, your presenter of the day. So I am tasked to report about ocean waters. My learning objectives are describe ocean waters, list and describe the layers of the ocean waters, explain the characteristics of the ocean waters, illustrate strategies on how we limit future warming and combat ocean acidification. So when we speak of ocean waters, an estimated 97% of the world's water is found in the ocean. Because of this, the ocean has considerable impact on weather, temperature, and the food supply of humans and other organisms. Despite its size and impact on the lives of every organism on Earth, the ocean remains a mystery. More than 80% of the ocean has never been mapped, explored, or even seen by humans. Why What you might not have heard, though, is that sea waves can move at of miles per hour, or that scientists have more detailed, more extensive maps of Mars than they do of our own oceans. The following little known truths about the ocean are sure to blow you out of the water. Next, let's proceed with my activity. So this is an ocean layers activity. It is a learning from home activity. So if you will watch this video, you will learn how to make a DIY layers of the ocean, and in this sense, you will familiarize the layers of the ocean by demonstrating the experiment of surface tension. Now let's proceed with my discussion. What are the layers of the ocean? So as you can see here in the picture, these are the layers of the ocean. So we have 5 layers of the ocean, and we will describe each zone. So number one, epipelagic zone, or this is what we call sunlight zone or light zone. So in this zone, it covers 2 to 3% of the ocean, and it is the upper layer of the ocean. This zone receives most visible light, and it receives enough light for photosynthetic to occur. So these are the animals that lives here: blue whale, dolphin, sea turtle, jellyfish. Okay, it is 200 meters deep. Number two, we have mesopelagic zone, or it is a twilight zone. So this is 200 meters to 1,000 meters deep. So it receives little light. So organisms lives here are called bioluminescence organisms. So when we speak of bioluminescence, this is a living organisms that produces light. So here are the marine life that lives here. We have crab, octopus, swordfish, wolf eel, catfish. Okay, we have next zone, bathypelagic zone or the midnight zone. So in this zone, it covers from 1,000 meters to 4,000 meters deep. So it has a constant darkness. So only light in this zone is the bioluminescence organisms. So in the temperature of this layer is about 39°F or 4°C. So we have here the organisms. We have blobfish, squid, viper fish, and we have anglerfish. Okay, so next zone we have abyssopelagic zone, or this is from the Greek word abyss, meaning no bottom. So it covers from 4,000 to 6,000 meters deep. So we have here few creatures that are live here. We have sea stars, shrimps, and squids. We have the last zone. We have hadal pelagic zone, or this is what we call trenches. So it is the deepest zone. So the temperature is above freezing from 6,000 meters to 11,000 meters deep. So here are the living organisms that lives here: starfish, leopard fish, sea cucumber, and tube worms. So these are the 5 layers of the ocean. Next, we will discuss and describe the characteristics of the ocean. So we have here the picture. So the picture means the salinity of the ocean. Okay, when we speak of salinity, it is the amount of solid material dissolved in the water. So we have here the percentages of dissolved solids in ocean water. As you can see here, we have the sodium and the chlorine is the most abundant. That's why the ocean is very salty. So we have here chlorine, 55%, sodium, 30%. We have magnesium, 7.7, sulfur, 3.7, calcium 1.2, potassium 1.1, and the others 0.7%. Okay. Next, we have the characteristics of the ocean is the temperature. So ocean water temperature increases when it receives insolation of the sun. Temperature of ocean water is not same. Rather, it varies from place to place and time to time. So it has various factors affecting ocean water temperature are number one, so latitude. So temperature of ocean water is more near to equator and less at poles. It is because the more heat received by the sun near equator are compared to poles. So when we speak of latitudes, we have here the low latitudes. So it is near equator. It receives all year warm surface waters. So if it is in high latitudes or it is in poles, the ocean water receives less sunlight. Okay, the last one, we have the density of the ocean water. Okay, so density, it is a measure of how heavy it is for the amount measured. So the density affects the depth of the ocean. It affects the temperature of the ocean, and also it affects the salinity of the ocean. So if the depth increases, the density also increases. And if the temperature decreases, meaning it is cold, very cold, the density increases. If the ocean salinity increases, the density increases also. So we have here the graph. So we have here the line. It is what we called, as you can see here, it has a curved line. We have the word pycnocline. So when we speak of pycnocline, it is the layer of the ocean in which water density increases rapidly with depth. Okay, so those are the characteristics of the ocean. So we have the salinity, we have the temperature, and we have the density. Okay, last topic that I will discuss is about how to combat ocean acidification. Okay, so I will just read the questions to reflect on. If you will watch this video, you will answer the questions below. Number one, so what is ocean acidification? What are the causes of the ocean acidification? And number three, how does ocean acidification affects marine life? And number four, in your own way, how will you combat ocean acidification? Okay, now let's proceed with my summary. So, how the oceans formed. So scientists have developed a number of hypotheses about how the oceans formed. Though these hypotheses have changed over time, one idea now, the wide support of Earth scientists, called the volcanic outgassing theory. So this means that water vapor given off by volcanoes erupting over millions of billions of years ago cooled and condensed to form Earth's ocean. So it is formed from volcanic outgassing theory. Okay, next we have present ocean formation. So we have here the picture. Okay, so as you know, the continents were not always in the same shape or position as they are today. Because of the tectonic plate movements, land masses have moved about the Earth since they were created. So about 250 million years ago, all of the continents were arranged in one huge mass of land called Pangaea. So in this picture, this map is called Pangaea. Okay, so this means This means that most of Earth's water was collected in a huge ocean called Pantalasa. Okay, so we will proceed now to picture. This is the Pantalasa Ocean. By about 180 million years ago, Pangaea had become to break apart because of continental rift. So this then separated the Pantalasa Ocean into separate but connected oceans that are ocean basins we see today on Earth. Okay. So next, we will proceed now sa significance of the oceans. So what are the significance of the ocean? So the ocean is home of an innermost amount of life. This includes many kinds of microscopic life, plants and algae invertebrates like sea stars and jellyfish, fish, reptiles, and marine mammals. So we depend on the ocean as a source of food. So we know the ocean is a source of food and even the oxygen created by marine plants. Okay, finally, the ocean provides the starting point of the Earth's water cycle. Most of the water that evaporates into the atmosphere initially comes from the ocean. This water in turn falls on land in the form of precipitation. It creates snow and ice, streams and ponds, without which people would have little fresh water. So a world without oceans would be a world without you and me. Okay, so that's all. Thank you.
And move on to our next topic, the ocean floor. So, what is the ocean floor? An ocean floor is literally the floor of the ocean. It's the bottom of the ocean when you dive. All floors of the ocean are known as seabed. The structure of the seabed of the global ocean is governed by plate tectonics. So most of the ocean is very deep, where the seabed is known as the abyssal plain. Now, oceans make up 70% of the Earth's surface. There are hundreds of seas and oceans in the world. We have five major oceans: the Atlantic, Pacific, Indian, Arctic, and Southern. So I have here the illustration exploring the seafloor. The ocean floor has the same general character as the land areas of the world. So it has mountains, plains, channels, canyons, exposed rocks, and sediment covered areas. There is a lack of weathering and erosion in most areas. However, this allows geological processes to be seen more clearly on the floor than on land. Undisturbed sediments, for example, contain a historical record of past climates and the state of the ocean, which has enabled geologists to find a close relation between past climates and the variation of the distance of the Earth from the Sun, the Milankovitch effect. Because electromagnetic radiation cannot penetrate any significant distance into the sea, the oceanographer uses acoustic signals, explosive and earthquakes, as well as gravity and magnetic fields to probe the seafloor and the structure beneath. Such techniques, which now include the capability to produce a SWOT or two-dimensional description of the seafloor beneath a ship, are providing increasingly accurate data on the shape of the ocean. So its roughness and the structure beneath. So we have satellite techniques are more recent in the development because the shape of the sea surface is closely related to that of the seafloor due to gravity. Satellite measurements of surface topography have been used to provide a global view of the ocean bottom. They also have provided data for an accurate mapping of such features as seamounts. So many of the important features of the ocean are hidden in the deep water. We have main divisions of the ocean floor. Number one is the continental shelf. Continental shelf is the shallow portion of the ocean which lies close to the continental margin. It is actually a part of the continent sloping gently towards the seafloor. The average depth is more than 150 to 200 meters. The continental shelf may be formed either by submergence of land or by change in the sea level. Number two The second main division of the ocean floor is the continental slope. Continental slope is beyond the continental shelf, where the sea floor slopes downward. So its average slope is between 2 degrees to 5 degrees and extend up to the depth of 3,660 meters. So the steep-sided continental slope separates continental shelf from a deep sea floor. Continental slope has been considered as the area of termination of the continent. Then we have the continental rise. The continental rise is gently sloping area at the end of the continental slope. The average slope of this region is not more than 1 degree. It becomes very flat towards the deep sea floor and virtually merges with the abyssal plain. And lastly, abyssal plain. At the end of the continental slope and rise, abyssal plain occurs at the deepest portion of the ocean. So it is in 3,000 to 6,000 meters in depth, covering nearly 40% of the ocean. It is completely plain and is covered by sediments of terrigenous and shallow water origin. So we have the features of the ocean floor and what is in the deep ocean floor. We have the barrier island. It's a low sandy island that lies parallel to the shoreline. Next, we have the bank. A bank is a low flat region on the continental shelf. And then we have the seamount, a steep-sided mountain that rises from the ocean floor. And then we have the geo, is a seamount that has eroded so that it has a flat top and is underwater. Mid-ocean ridges that marks places where two tectonic plates are separating and new ocean crust is being made. And lastly, we have the trench. The trench is the deepest part of the ocean. Now, to learn more about the ocean floor, please click this link to watch the video. I think that would be all, and have a good day.
Good day, everyone. I will be presenting to you the tides, currents, and waves as part of the lesson of Earth's water. So this is our site for us to learn more about tides, currents, and waves. I am your presenter for today. I am Irish Beth Aya, a student of Master in Education teaching General Science. At this time, before we are going to discuss further about tides, waves, and currents, each of these links will lead you to an activity sheet about tides, currents, and waves. Ocean currents, waves, and tides are three types of movement that affect the waters of oceans, whereas currents are horizontal movements of ocean waters, waves and tides are a kind of vertical movement. Ocean waters move under the influence of forces originating due to temperature, salinity, and density differences, as also due to external forces like the winds and the gravitational influence of the sun and the moon. I have here a representation of tides, currents, and waves. So look at the moving pictures presented here. What do you think are the differences of these three ocean or water movements? To give us an overview, a tide is a vertical movement of water which are caused by gravitational forces from the sun and the moon, while currents, a horizontal movement of water that are influenced by an even heat from the sun on the equator and cooler poles. Waves, a vertical movement of the water generated by action of wind on the surface of the ocean. So that is how the three water movements differ from each other. But let's go further and deeper on our understanding on the three water movements. Let us watch the video about how tides are formed and answer the guide questions below. You can send your answer on our classwork as an attachment. So here are the guide questions of this video. First, how tides are formed. Second question, differentiate high tide and low tide. And the third one, can low or high tide happen twice? So in order for us to answer these questions, let us view this video here. So based from the video, it was explained how tides are being formed. It is due to the gravitational force coming from the sun and the moon towards the earth. So it was also explained in the video how tides are being formed. In the video as well, it was well represented on how tides occur in the waters of the oceans and seas. And it was also discussed the different types of tide and how high tide and low tide happens. So I know that the video was very easy to understand and it was a simple representation of what tide is. So you can answer now the questions given to you in the classwork. Now, let us proceed to another video which will focus on the ocean currents. So let's explore this video and let us identify how do currents work. So basing from the video that we have watched earlier, we can understand how currents are formed in ocean waters or in sea waters. There are many factors that affects or creates currents. We have the density of the water, we have the wind and the tides. So to further understand currents, let us do a simple experiment which will enable us to test and to see how really currents. So kindly open the link which is Ocean Current Worksheets. In this worksheet, you will find the procedure of the simple experiment that you are going to conduct, and the instruction is video yourself doing the experiment and send it to me, attach it in the classwork so that I can see you doing the activity and at the same time answer the guide questions present in the worksheet. So, okay, and then after that, let us now proceed to waves. So let us study waves by looking at or watching at this video. So as you have seen, the concept of wave is due to the wind that is present in the sea waters or ocean waters. It depends on the intensity of the wind. And also we have what we call tsunami, which is a wave created when there is an earthquake that is produced at the bottom of the ocean or the sea floors or sea volcanoes that is present under the water. So in order us to have an interactive simulation of wave, so let us click this link for us to experience and to explore waves more. So I have here the illustration of wave. We have seen earlier the concepts of tides, currents, and waves. So let us study deeper these three water movements that are very common in our ears, but somehow we need to have a deeper understanding on each of them. So let us start with ocean currents. Ocean currents are caused by a combination of three factors: the rise and fall of the tides, prevailing winds, and density differences in ocean waters due to differences in temperature and salinity, or the thermohaline circulation. The direction of movement of an ocean current is mainly influenced by the rotation of the Earth. Due to Coriolis force, most ocean currents in the northern hemisphere move in clockwise manner, and ocean currents in southern hemisphere move in an anti-clockwise manner. While tides are very long period waves occurring once or twice a day, which move through the oceans in response to the gravitational forces exerted by the moon and the sun. The major cause of the occurrences of tides is the moon's larger gravitational pull on account of its proximity to the earth. The difference in height between a high tide and a low tide is called the tidal range. Spring tides occur when the sun and earth and moon are in a straight line. This happens twice every lunar month. Once when the sun and the moon are on the same side of the earth, or new moon, and again when they are in the opposite side, which is full moon. Neap tides occur, on the other hand, 7 days after a spring tide, when the sun and the moon are at the right angles to each other with respect to the earth, thus countering the gravitational pull exerted by earth by each over the earth. Neap tides thus lower spring tides and also occur twice in a lunar month during the first and the third quarter moons. Waves are created by energy passing through water, causing it to move in a circular motion. Waves do not transport water. They transmit energy across the oceans, and if not obstructed by anything, they have the potential to travel across an entire ocean basin. Although a large amount of energy and momentum is present in a wave, there is a very little forward motion of the individual water particles in the wave. The three main factors that cause oceanic waves are the following. First, the speed or the velocity of the wind. Second, the distance over which the wind blows over the ocean. And the third, the duration for which the wind blows. So these inputs here present in the sites are notes that somehow summarizes the video that you have seen earlier. We still have an additional inputs on tides, waves, and currents. So if you're going to click this arrow here, it will give you an information about tides. So additional information about tides: the observable rise and fall of the sea level is influenced strongly by shoreline topography, ocean currents, and the distribution of the continents on Earth. As a result, different tidal cycles can be experienced in different regions of the world. Depending upon your location near a shoreline, you may experience any of the three tidal patterns. So we have three tidal patterns: diurnal, semi-diurnal, and mixed semi-diurnal. An area has a diurnal tidal cycle if it experiences one high tide and one low tide every lunar day. These are the most uncommon of all types and occur on the eastern coast and Southeast Asian land masses and the Gulf of Mexico. While semi-diurnal as this cycle if it experienced two high and two low tides of approximately equal size every lunar day. These are the most common type and occur on the eastern coast of all continents and the western coast of Africa, Europe, and Central South America. While the mixed semi-diurnal tides or tidal pattern has a tidal experiences which has two high and two low tides of different size every lunar day. Most commonly occur along the western coast, but also along some eastern coast like those of Japan, Philippines, Madagascar, East Africa, Central South America, and Caribbean Sea. For the waves, we have another or additional information about the waves. So there are three different types of wind-generated waves that can develop over the ocean as follows: the ripples, the seas, and the swells. Potentially hazardous waves can be generated by unsettled weather condition like a hurricane. The strong winds and pressure from this type of severe storm causes a storm surge, a series of long waves that are created far from shore in deeper water and intensify as they move closer to land. So like what happened in the Typhoon Yolanda, because of the strong wind and the heavy downpour of rain, it causes storm surge wherein the waters in the sea goes to the land and it flood. And then another type of waves is the tsunami or the seismic sea waves, which is a series of waves caused by a displacement of a large volume of seawater. So tsunamis are generated by displacement of large volume of water due to underwater earthquakes, volcanic eruptions, slumping of sediments piled on the continental shelves down the continental pole, meteorite impacts, and other underwater explosions. So these are the other information that we can have about waves. And lastly, for currents, we have this information present here. Types of ocean currents can be classified into a number of types on a different criteria. Depending on the water temperature, they may be classified a warm ocean currents or a cold ocean currents. Another basis are the depth of the currents. Ocean currents can be classified into a surface currents and deep currents. So this was also discussed during the presentation of the video. So this is the content of the site where you can learn more about tides, waves, and currents. So through this, you can have an independent learning while at home during this pandemic. Once again, thank you and God bless.